founded in 1986. So we have worked with, and our central goal is to work with volunteers to collect water quality data on waterways. And so for 26 years, this has been our central aim, is to empower communities with scientific tools to monitor, protect, and restore Pennsylvania streams. And being based out of Dickinson College, we have a faculty science director, Dr. Candy Wilderman, two, soon to be three full-time professional staff, myself included. And then we also employ 10 to 14 Dickinson College students that also work for the organization. And I'm here with my colleague today, Elizabeth de la Reguera, who's going to be helping with the presentation and then the hands-on activities. So, all right. So the first thing that I'm going to do with the talk is to talk a little bit about the science of shale gas drilling and how does that pertain to the role that communities can play with water quality monitoring. So the first thing I always like to do when we do our Marcellus monitoring workshops is to show this map. So as you can see, there's light pink and dark pink basins. The darker pink is where active hydrofracking is taking place. It's considered to be an active gas field. And so you can see over here in the Appalachian Basin, my laser is not working, so we'll improvise. So over here in the Appalachian Basin, you see the Marcellus and the Utica shale formations. The Marcellus and the Utica basins, the Marcellus used to be an ancient inland sea that covered the majority of the Appalachians, and so, 350 million years later, this is where we are with natural gas. Really, some of the more famous shale gas plays are the Barnett down in Texas. We've learned a lot from Texas's experience, and then also looking out in Wyoming and looking at some of their shale gas basins, we've learned a lot from them as well. Okay, so the next couple of slides show some maps which may or may not be easy to see from where you're sitting. They're from the Marcellus Center for Outreach and Research, which is based out of Penn State. And I really like these maps because the first map here shows the depth to Marcellus. So one of the things that we talk about a lot with drilling or hydrofracking in these shale gas basins is the amount of water that is needed to go after these gas plays. And what this map does is it shows you the depth, so you get a sense of how far deep you have to go before you start your 1 to 2 mile horizontal drilling. So some of the hot counties in the state, Bradford up here in the northern tier, you can see that they have nice deep shale gas basins, and out here in the southwest, Bradford, Washington, Greene counties are have the most wells in the state, and so you can see the very deep shale basins.
Excuse me, when you say deep, okay, deep. Maybe this is going to answer the question. You mean deep far down?
Deep
this is going to answer
from the surface, how far down you have to go. So like in Bradford and Greene, thickness. Okay. That's the key one, is looking at thickness. So in like Bradford, Washington, and Greene, it's close to 2 miles vertical that you have to drill to even get to the shale gas. So the next map here gets at the thickness of Marcellus shale. And so one of the reasons why this is really important is they're going after the most profitable or expected to be profitable areas first. So up here in the northern tier, you can see that very rich red, brown colors up there. That's a very thick shale gas basin up there. And so the thicker the deposit, the more gas that you should be able to get out of it. Is there anyone here from northwest Pennsylvania? Okay. So when it comes to Marcellus, what county are you in?
Cameron and Elk.
Cameron and Elk. Well, you're kind of on the border of where there's some profitable areas and non-profitables. One of the things you hear a lot about with Marcellus up in places like Erie, Mercer, Crawford, Venango counties is the fact that there's what's called folded geology. And so those are shale layers that are very thin, they're not very thick, and it's folded, so it's not easy to go after the gas. But we also have Utica. So that's something else to keep in mind. So in some areas, like the counties that I listed in Northwest, they've determined it's not profitable to go after the Marcellus gas, but Utica presents a different opportunity. So when you look at the shale gas basins, Marcellus is on top and Utica is underneath of that. So when you look at some of the numbers, depths to Utica, when you look at the same areas, let's say Bradford, in the previous slides we were going about 7,000 feet to get to the Marcellus and Bradford. With the Utica, you're looking at anywhere from 10 to 12,000 feet to get to the Utica Shale. So it's, again, we're adding yet another depth to be able to go after those gas plays. So now when you look at Northwest, Erie County, for example, they tried to drill in Marcellus, determined that it wasn't profitable, and they've already drilled their first Utica well. So for those areas where there's folded Marcellus geology, Utica might be the more profitable shale layer. Yes, sir?
So the deepest Utica there in the middle, is that around Center Clearfield County, or what is that? The darkest, deepest?
The 1400 is over here, more in the southwest. If I'm getting my county geology or geography correct, that's Westmoreland, Westmoreland and Armstrong. Cambria, that's I think where the 1400 is. Center County has only, like half of the county has some Marcellus and Utica in it. And for Utica, you're looking at 8,000 feet to where it is in Center County. So one of the reasons why I bring up Utica is just making sure that people know that this is on the horizon, and in some places in Pennsylvania we've already started to drill that. So Erie is a really great example of how it was folded geology in the Marcellus, but when you look at the Utica, it has a very rich thickness of 200 to 250 feet thick. So it's just something good to know with some of the basins and thinking about where might they go next with drilling. Okay, so this slide, again from Penn State's MyCore website, so this shows the rate of drilling once drilling began in 2005. So in 2005, they'll cycle back through, we had 60 wells in 2007, 230 in 2008, 685, 09, shy of 1,410, and through November of this past year, we were just shy of 1,700 wells. So you can see that the rate of drilling is increasing, and one of the things we're also seeing is the percentage of Marcellus or shale gas wells in the state is increasing. Some of the historic shallow gas wells are on the decline, and Marcellus and other shale gas basins are in the incline.
So these are active, not just drilled, prepped wells. These are active producing wells.
This schematic is producing wells. They do have maps that show where permits are as well. So. These are actually the wells. Okay, so are folks familiar with the hydraulic fracturing process? Okay, yes, sir.
Do you have anything on where the deep aquifers are from the other map?
No.
Okay.
Sorry. Yeah. So folks are familiar with how hydraulic fracturing works. Basically you have your vertical well, and then you have to turn horizontally. And with shale, you actually have to fissure and break up the rock to be able to get at the gas pockets. So with traditional vertical shallow wells that we've had in Pennsylvania since the start of the 1900s, over geologic time, what happens is, those are rock formations that are very porous. The gas were able to migrate over millions of years and essentially, form in pockets where essentially you're taking a straw, plugging it, and getting it out. With Marcellus, with it being shale, it's very impervious, not very porous at all, as you guys might know if you have any shale clays in your farmland, you'll know some of the issues with permeability with that. Same kind of concept with hydraulic fracturing. You actually have to go in and break up the rock to be able to release the gas. And so that's why when you're looking at the number of chemicals being used, the amount of water that's used in this, that's why it's a much more intensive process. If we had had more time, I would have shown the industry video. That's a drilling video. And
we have that. I think we have links to this video, which is really interesting to watch online. I'll just write the site where we're trying to archive these things for
Sounds
everyone.
good. It's an industry-produced video describing the hydraulic fracturing process, and it does a very good job of kind of breaking down the process simply. It does overlook some categories with like casing a well and things like that, but you know, it's a very good explanation of how hydraulic fracturing works. Okay, so this is yet another thing that I've grabbed from MyCore, Penn State MyCore. One of the questions we often get at workshops, and granted, we're a surface water organization, so drinking water is not our expertise, but we often get asked questions about casing and what does it look like if you're on a well pad and looking down a well. You know, through the first groundwater aquifer, you're going to have casing that extends out about 2 feet. And some of the regulations that came about in 2010 when we were seeing high incident of groundwater contamination with hydraulic fracturing was the requirement of having additional layers of casing through your groundwater aquifer. And so, so you have these 4 layers, starting as far out as 2 feet, then coming into about 20 inches, then a little more than a foot, and then the very central casing is 5.5 inches. So that 5.5 inches casing is what continues down the rest of your vertical well, and then what turns horizontally. But you only have the 4 layer of casing through your groundwater aquifer. Yes, ma'am.
Am I correct to also believe that it's all, the casing is made of cement, correct?
Piping and cement, yeah. Yeah, yes. Okay, so one of the games we like to play, ALLARM has conducted 29, no, we're at 30 now. We've conducted 30 Marcellus monitoring workshops throughout Pennsylvania primarily, and we've also done one in New York and one in West Virginia. And one of the games we like to play is what kind of truck is that and how is it related to the gas industry? And so we were able to see some trucks that had some of the casing pipes and things like that, so that's why I included that slide. Okay, this next slide I've borrowed from colleagues of ours at Trout Unlimited, which goes through the differences in drilling. So a lot of the verbiage you hear from industry is talking about the fact that hydraulic fracturing has been around for a very long time. Yes, hydrofracking has been around for a very long time. What hasn't been around for a very long time is this high volume hydraulic fracturing. So in traditional hydrofracking, when you're looking at shallow wells and things like that, you're looking at anywhere from 20 to 80,000 gallons of liquid to be used every time a well is hydraulic fractured or fracked. And then you're also looking at anywhere from 700 to just shy of 3,000 pounds of chemical additives. That's traditional hydrofracking. When you look at high volume hydraulic fracturing, you're seeing anywhere from 2 to 10 million gallons of water being used per well, and the amount of water is related to how deep the well is, so that those maps I was showing from the surface to where the shale is, depth to shale. So it's dependent on how deep it is and then how far out they're going with the horizontal drilling. And then the other big number that's very different with this is the amount of chemical additives. So with high volume hydraulic fracturing, you're looking at anywhere from 200,000 pounds of chemical additives to just shy of 1 million pounds. So it's a different ball game. So we always like to point out some of those differences out there. Okay, so this is an example of a drilling site. We like to include this in our slides because you have the drill pad, and then if you look around the drill pad, you can easily see at least 3 homes right around the perimeter, and then you have cows down here in the lower part of the picture. So it really gives you the sense that these things are right here in your own backyard. Drilling pads, like the actual pad where the drilling occurs, is typically less than 5 acres. Like I said in the previous slide, you're looking at anywhere from 2 to 10 million gallons of water being used. That's anywhere from 200 to 1,400 truck trips to supply water to the well. And then drilling pads must be 200 feet away from structures with potable water supplies, and then 100 feet from streams and wetlands. Not very far. Yes, sir?
The previous slide where it says traditional versus high volume, was that also the difference between vertical versus horizontal?
No, that isn't distinguishing between the differences between vertical and horizontal. As I understand it, the way how my colleague presents it, that reflects like traditional horizontal.
Traditional, so.
Yeah, so but that's not very, like, you're not looking at 1 to 2 miles horizontal. It's primarily, it's a much shorter distance. So, okay. So this is a picture, again, that we borrow from colleagues of ours at Trout Unlimited. To get one of the other questions that we get is, is it one vertical well with multiple horizontal legs coming off of it? And the answer to that is no. For every horizontal angle that you go in, you have your own individual vertical well. And one of the reasons why you do that is because the shale is such a tight-bound rock, very impervious, as I was talking about before, you're going to angle your drilling so you can do your fracturing to get at your pocket of gas as best as possible. So there's a limit, there's like a range of how far out you can actually fissure the rock. On average, you're looking at about 500 feet. So they're going to position their horizontal wells to be able to cover your full gas pocket distance. Does that make sense? All right, so where do we fit in with all of this? Why volunteer monitoring? One of the reasons why volunteer monitoring is the Pennsylvania Department of Environmental Protection has less than 200 permanent water monitoring sites across the state. And the amount of trainings that we've done, we've trained just shy of 600 volunteers. And so that's the potential of adding so many more sites across the state that can be monitored. And when you have local communities engaging in stream monitoring, local communities can see the activity going on and be better eyes, ears, and voices of the stream. So that's one of the reasons why we say why volunteer monitoring. Volunteer monitoring has been around for a very long period of time. Dates back, the first version of volunteer monitoring dates back with the National Weather Service. They started the rain gauge monitoring program in the 1890s. So that's 120 years ago that citizens have been involved in data collection. And then all across the United States, you have all sorts of forms of volunteer monitoring and citizen science projects. And we could spend a whole afternoon talking about it, but I won't. In Pennsylvania, we have a very rich history of volunteer monitoring and watershed engagement, or communities engaging in the protection and preservation of their watersheds. One of the reasons for that is Pennsylvania has more stream miles per land area than any other state in the nation. It's pretty significant. So we have, it's phenomenal. We saw an increase in community groups engaged in watershed protection from 125 documented in 1999 to over 580 documented in 2005. That's a huge growth of time, a huge growth of numbers of communities engaging in these types of issues. And I think that was tied to the Pennsylvania Growing Greener grant program. But still, we have a very active constituency and citizenry in Pennsylvania that's engaged in water quality issues. And so really, Pennsylvania volunteer stream monitoring really started to pick up 25, 27, 28 years ago, so in the 1980s. So when we, ALLARM has worn many hats with stream monitoring and the different issues that we've engaged in. We started out as a group that was very interested in collecting data on the effects of acid deposition on Pennsylvania streams. In 1996, we transitioned to working with community groups that were concerned with their own watershed and had various issues popping up in their watershed that they wanted to address and use scientific data to back them up. And then in 2009, with the whole Marcellus activity starting to pick up, our phones started to ring much more frequently, and people were asking, what is the role of a volunteer monitor with this whole Marcellus Shale business? And we asked ourselves, I'm sure there's a role. Let's figure out what that is. And we were very fortunate in 2010 that our science director was on sabbatical, and she worked with my colleague Jenny Monosmith and a team of students to develop this Marcellus monitoring protocol that we've been using all throughout the state. So the first question that we work with communities to determine before they start any type of monitoring program is, why are you monitoring? So in our protocol, we laid that out. And number one reason why we're doing this is early detection and prevention of contamination of streams, of contamination of flowback water in small streams. And when I say flowback water, that's the water that's coming back up out of the well, which is very salty, and Elizabeth will talk about that in a little bit. Number 2 is to document the stream quality, looking at cumulative long-term impacts. Number 3 is community education. And the language here that's highlighted in the green is the data collected using this monitoring protocol are not intended to be used for legal purposes. Really, this protocol is a red flag warning system. This is, if a volunteer captures a pollution event, they're calling the DEP regional office to have them respond appropriately to it. You need agency or lab certified collected data to hold up in court. And that being said, there are some groups that are planning on using their data for legal purposes, but our manual is created with that intention, so we always have to have that stated. All right, I'm going to hand it over to Elizabeth to walk you through your chemical parameters.
So Marcellus Shale monitors, they focus on 3 basic categories to monitor. Chemical monitoring, which includes conductivity, total dissolved solids, barium, and strontium. The monitors will also focus on visual assessment and stream stage, or the quantity of water in the stream. Conductivity is the measure of the presence of ions in the water. So inorganic compounds such as dissolved salts and heavy metals are good conductors, and organic compounds such as pesticides are poor conductors. The way you measure conductivity is at the bottom of the meter there are 2 probes, and there's voltage applied between the probes. And that, once it's immersed in water, it gives you a conductivity reading. And these are some ranges of conductivity in different waterways. Distilled water is 0.5 to 3 microsiemens per centimeter. And industrial waters are up to 10,000 microsiemens per centimeter. Total dissolved solids is essentially the same thing as conductivity, except that TDS measures the mass of ions in the water. And the way you measure TDS is the same probes that have voltage running between them. They'll first measure your conductivity, and then a equation is applied within the meter, and that's how you receive a TDS reading within the same meter. But you can, however, measure TDS directly by using a gravimetric method. In ranges for TDS, fresh water is typically less than 1,500 milligrams per liter, while saline water is greater than 5,000 milligrams per liter. So again, the 2 probes on the bottom of your meter, there's voltage applied between the 2 of them, and that gives you your conductivity reading, and then a conversion ratio factor is applied, and that's how you receive your TDS reading. So why do Marcellus monitors measure TDS and conductivity? The frac water mixes with the natural brine, which is within the shale, and so when the flowback water comes back up that well, it contains high concentrations of salts and metals, and that's what TDS and conductivity are reading within the meter. So Amy Bergdale from the US EPA went out into different Marcellus Shale regions and tested for TDS in flowback water. And these are some readings that she received. And you can see how high they are compared to the freshwater TDS readings, which is less than 1,500. And she's finding readings of 217,000 milligrams per liter. So the way we chose the Lamont meter to use is we went through all the meters that were $200 and less. And then we chose our top 3 meters. And from those top 3, we asked Dickinson students, faculty, and staff to test these meters and give us feedback on them, see how well they worked. And it came out that the Lamont meter was the most accurate, precise, and the easiest to use for everyone. So that's how we ended up using the Lamont meter.
And quite nicely, it's also one of the more cost-effective meters that we tested, which is really nice.
So as Elizabeth mentioned, every time a volunteer goes out and does a water monitoring day, they will be getting their conductivity and total dissolved solids reading. In addition to collecting baseline data, in an ideal situation with this protocol, you'd have at least a full year to be able to capture baseline data in your waterway or your watershed prior to drilling beginning. And then what the protocol recommends is once drilling starts to begin in your watershed that you transition to a weekly monitoring schedule. And so that's an ideal situation. We also have a contingency plan for those watersheds that are where hydrofracking is already taking place. Where barium and strontium come into play is barium and strontium are naturally occurring metals found deep underground, and they are what we call signature chemicals, indicating that the spikes in conductivity or total dissolved solids is tied to a Marcellus flowback pollution event. So the conductivity in the total dissolved solids is the canary in the coal mine, and then the barium and strontium analysis helps to confirm that a pollution episode is related to Marcellus shale. So just like with conductivity and total dissolved solids, we want people to be able to establish a baseline for these two indicators. And so it's encouraged that at least twice a year that certified lab analysis or certified lab data is collected and analyzed for barium and strontium. Okay, so the next aspect of the protocol, while a volunteer is out in the field, is collecting stream stage monitoring or cross-sectional area of the stream. And really what we're trying to do with this is get a sense of how much water is in the stream right at the monitoring site, and then use that to compare the readings between the amount of water in the stream and your conductivity values. So there is an indirect relationship between conductivity and flow. So when you have a large rain event or something like that where there's a lot of water in your stream, you're going to see your ions being diluted, so you'll see lower values of conductivity. And vice versa, in a low flow situation, you're going to see some higher values of conductivity. Yes, sir?
With the barium and strontium, how are you testing for those?
A volunteer collects a sample out in the field, and then it's sent to a certified lab for analysis. Yes. So while a volunteer is out in the field, they'll get a width by an average depth measurement of water at their site on the day that they go out and monitor. And so one of the things that we have as part of our criteria is, how do you determine whether or not you have a pollution event is, looking at this comparative or surrogate flow reading. So what you can see up here on this chart is you have these pink graphs, pink highlighted areas where you have a flow of 1, and you look at the conductivity, and the very top one you have 178 value microsiemens per centimeter. Then down here in September, you have another flow of 1 and a conductivity reading of 183 microsiemens per centimeter. And then down here this first week in November, you have a flow of 1 and a conductivity reading of 680. And so a volunteer is going to ask themselves, is this a pollution event? And the criteria that we developed is if a conductivity value is 3 times higher than a conductivity value at a comparable flow, then that's the time where a volunteer will collect a sample for barium and strontium analysis and go ahead and call the DEP regional office to report a potential pollution event. That will become abundantly clear when we do our hands-on activity, I promise. The other thing that people will be doing as they're going out in the field on their weekly sampling basis is doing visual assessment. Colleagues of ours, Veronica Koptis with the Mountain Watershed Association was here this morning to present on visual assessment. Did people attend that? Excellent. So there's 3 main categories with that. Earth disturbances, spills and discharges, and gas migration and leakages. These are examples of earth disturbances. You see these erosion and sedimentation control measures around development sites. Essentially what we're training volunteers to do is to determine whether or not they've been implemented and or maintained properly. So this collapsed silt fence is an example of an event that a volunteer can say, hey, the silt fence around this well pad has collapsed, it's not doing its job properly, they need to fix it. The obvious thing for people to look for are spills and discharges. And these are pictures that we received from colleagues of ours at the Delaware Riverkeeper Network. This is a drilling fluid spill at a Cabot site in Dimock, Pennsylvania, and this pollution event was captured by a volunteer, which we're very proud of. So you can see obvious discoloration at the site where the spill had taken place, and so that's these top 3 pictures, and then this bottom right picture is about a mile downstream, and you can still see that the water is very cloudy. The last category gets at gas migration and leakages. This is, one of the things that we're seeing, especially in areas where there's history of coal mining. Out in Greene County, this right-hand picture over here is actually me lighting a gas bubble migration, bubbling in a creek on fire, and that site is in a Class A trout stream, so it's, has naturally occurring or spawning trout, and it started to have gas migration about 7 months after a Marcellus well was drilled about 2 miles away from the creek. And the idea and theory that the community has, and a couple of people have been talking about, is out in Greene County, where you have this history of longwall mining, you have these caverns and spaces for the gas to migrate, and you're seeing gas migration popping up in lots of different places that you don't see before. And so the idea at the baseline is, check and see if you have naturally occurring methane migration, and then tracking that movement should it occur in your watershed.
What did people notice first? Like they saw bubbles?
Yeah, you just see these constant bubbles.
Flag.
Yeah, and where this was, there was just within like a 30-foot square area, there were probably 7 areas where there was bubbling happening at different rates. And really, I don't know the safest way to test, the quick and easy way to test to see if it's methane is to try to light it on fire. But that's, depending on the rate of bubbling and stuff like that, we might think about safety considerations around that. But, it was just a flare-up. Okay. Where will you, yes, ma'am?
I'm sorry, there's a question about 2 slides back about Dimock. Is that the same time that the big fish kill happened there?
There was obviously biota was affected with this. I don't know if that was timed. This was in September of 2009, so.
Okay, I think we were on the same time.
Okay.
I just wasn't sure, I'm sorry.
Sounds good. All right, so another thing that we cover in our workshops, and is a big step for volunteers, is determining where will they monitor. And it's I would say it's one of the more challenging steps in the monitoring process, is determining where you're going to go. And so one thing that we do is we train people how to use the DEP website and their electronic notification system to receive information on well drilling permits. Is this something that people have done before? So this is something first step. So if you know you have hydraulic fracturing happening in your area and you want to know if it's going to be coming right near you, is you can go to the DEP website and either sign up for electronic notification, and we recommend that you choose municipalities that you're in and then surrounding you, or you can go on and then you get these email updates every time a well permit comes in, and then you have to check and make sure it's either Marcellus or a traditional vertical well. Or the other thing that you could do is you can go to the DEP website, and this information is updated weekly, and then download the well permits in your area, in your county, or however you want to organize it. And one challenge with this is DEP will state it'll let you know when the well has been permitted, but you don't get an additional notification of when that well becomes active. So essentially what we train people to do is to kind of keep the laundry list of the different wells that have been permitted in their watershed or in their county, and then as a community just kind of keep an eye on when the trucks start coming in, and then you can anticipate that they'll turn active pretty quickly. Yes, sir?
I have another quick question about you were saying on the pad inspection, one of the things they can do is they can go out and look at the areas to see if there's any problems with silt fences or what. And are you allowed to go to these pads, and are anybody ever chased off or?
It's a great question, and our Marcellus monitoring workshops are just shy of 6 hours long, and I think we probably spend an hour and a half on choosing site locations and talking about the different factors of consideration. So for that particular visual assessment, category, where you're looking at erosion and sedimentation control measures, that's contingent upon a volunteer being able to get landowner permission to be able to walk around the site. Well pads are an industrial site, so you're not allowed on them, and I wouldn't encourage people to go onto a well pad site, but you can walk the perimeter if you have landowner permission and the whole 9 yards. Yes, sir?
What about state forest land? Because that's where all my water comes from.
All right, so state forest, that gets into the public category. So on state forest lands or areas that are public lands, you technically have the right to be able to access the land around the well pad, technically. That's not to say, we have colleagues that get chased out of state forest lands all the time. So it's important that if you're going to do stream monitoring to let people know that you're going to be doing it there. So.
Do they have to leave if the company asks them to leave on state forest land? Is there like a closure set up?
I don't know about the specifics about whether or not, what the agreements are with that. Well, with the volunteers that we know that do monitoring on state forest lands, we just encourage, they let them know that they're going to be doing it, where their site is, so on and so forth, so that people are all knowing about that. Because there's security trucks that run all the time around well pads. Yeah, I'm going to take this and then I'm going to keep moving.
My experience with that is that even if they wrongfully arrest you, they'll rather arrest you than have you there.
Yeah.
They'll take you away.
Ask questions later. First.
Yeah. It's tough. When I think about some of the colleagues that we have that have been run out of state forest lands just for driving around, it's pretty remarkable. So it depends on where you are and who you know and how well they know you. Okay, so the first step with determining well locations is to go and get the information from DEP. The second step is then mapping it out. Google Maps is a great tool for that, or we strongly encourage everyone to use topographic maps because you can map out the grid lines and everything like that. And then the third step is choosing your monitoring site. So a lot of times people in areas where they can collect baseline, they're like, well, we don't know where the wells are going in, so how do we choose our monitoring sites? And so we have this whole strategy of how to choose monitoring sites in baseline situations. And then once well activity begins in a watershed, we always suggest that there be some permanent monitoring sites and then some flexible sites to move around as the well activity picks up. Okay, data use. One aspect of our manual are what we call our decision trees. And so this is information on, okay, so I'm looking at my visual assessment checklist, and I see a spill. Who do I call, and where do I, it's a whole tree of is it, a threat to humans and people around them and wildlife? You call these numbers. If it's something that doesn't appear like a gas leak, for example, if it seems like it's going to be an immediate threat to those around, then you call the emergency personnel. If not, if you have methane migration bubbling in your creek, you're getting on the phone with DEP and then the Fish and Boat Commission and the whole 9 yards. With Marcellus pollution, in some ways it's a good thing, and then other ways it's not. All pollution events and episodes within Marcellus is streamlined through the DEP. So the DEP regional offices are the only offices that can respond to a Marcellus pollution event. We often encourage people to have strong relationships with the county conservation districts, but county conservation districts cannot go out and investigate a pollution event without the DEP telling them to. So with this particular type of pollution, you have to go through the regional offices first.
Go through whom? It's hard to understand.
The Department of Environmental Protection's regional offices. So there's the regional offices all throughout the state. Well, there's 5 of them. So depending on...
You have to get permission from them before you go to these places? Or?
What I'm saying is if a volunteer, yes, yeah, okay. So if a volunteer is out monitoring on a weekly basis and they get a spike in their conductivity, for example.
They get what?
Get a spike in their conductivity readings. So the canary in the coal mine that we're training people on. If it's what we consider to be a reportable event, they have to call the DEP regional office. And then from the DEP regional office, they will send out either their oil and gas inspectors or their water monitoring folks. And then they're the primary people to determine whether or not a pollution event is something that they can hold someone accountable for.
It could be there when you discover it, and by the time they get around to sending somebody, which could be who knows how long, it might not be there anymore.
That's true. That's one of the big challenges with it being streamlined through the regional offices. And with water quality data, it's a flash event. Depending on how much of a flowback water contamination spill it is, it may be there really quickly in a flash moment, or it could be there for multiple days. So it's really important for the DEP to respond to it quickly. And one of the things that ALLARM has done with colleagues of ours, including Trout Unlimited and the Delaware Riverkeeper Network, is to establish a relationship with the Oil and Gas Division at DEP. So this summer, I presented to the oil and gas inspectors with a colleague of mine from Trout Unlimited, and essentially what came out of that meeting is Scott Perry, who's the Deputy Director of Oil and Gas, told the inspectors that any volunteer trained on the ALLARM protocol is to receive priority treatment if they were to call in a pollution response or a pollution event. They are to be responded to immediately. And one of the reasons why they state that is because people are using science to inform the calls coming in. DEP regional office, like if you look at out in the Pittsburgh office, they're getting hundreds of phone calls with potential pollution events in the Marcellus region. Some of them can be very truthful. Some of them, might be false alarms. But the thing is when you have that rate of calls coming in, you have to have a way of being able to respond to it. And so you're very right. Not all pollution events get responded to in a timely manner. So that's one of the reasons why we established that relationship with the Oil and Gas Division.
Does the DEP have any ongoing monitoring with careful recording of data and findings, and that's something that should be publicly available for anybody to review? Do they have this at the present time in places like Dimmock and so on, or is it also hit or miss? My guess is it's hit or miss, but I hope not.
I'm going to keep my answer to that really brief. I'm not the DEP, so my understanding of the DEP's monitoring regime is, and before Secretary Hanger left, the DEP was able to add 10 additional sites specific for Marcellus monitoring, and then they were also able to add analysis for their already pre-existing monitoring sites throughout the state. But it's very dispersed, it's very spread out. It's less than 200 sites throughout the state of Pennsylvania, and so it is, depending on where the pollution event is, they may or may not have monitoring taking place in that particular watershed. So it could be, as you said, a hit and miss. All right.
And what would they do?
I'm gonna cap that. We can talk about it afterwards. It's a agency follow through it's a touchy subject. So, and I'm not the agency. So, all right. So with this protocol, the other thing that we have is quality assurance, quality control measures built in. So a lot of times we get pushback on volunteer collected data. And so we have additional measures built into the protocol to make sure that the volunteers are collecting the most credible data possible. First thing is they go through a 6-hour training. As you're going to learn today, you're going to learn how to calibrate a meter. They're calibrating their meters every other time they go out. They're doing replicates. They have a manual that documents all their procedures. And then the final thing is whenever we train volunteers, we encourage them to go through what's called a split sample analysis with our lab to verify that they are using their meters correctly. So the first time they go out monitoring, they'll get the reading with their monitor or their meter, record their data, collect a sample. They'll send that sample with their data to our lab, and then we'll test that sample using their meter and then additional meters to verify that they are using their meter correctly. And that aspect of our protocol is one of the reasons why volunteers get priority when they call in potential pollution events. Hands-on training, you'll get to that in a few minutes. Data management, I would say, is one of the challenging aspects of Marcellus monitoring is we do not have like a statewide repository for all the volunteer data that's being collected. That's something that we're working with a number of partners to try to achieve in the not too distant future. In the meanwhile, we have Excel templates that are available off of our website that people can use to monitor or to house their data group by group. Building a monitoring movement. Since the first group started doing monitoring, the Pine Creek Headwaters Association, the Pine Creek Water Dogs, they were the first group to come up with a volunteer monitoring protocol based on visual assessment. since they started, and a whole mess of partners, Del Riverkeeper Network, Trout Unlimited, Pasa, Mountain Watershed Association, and ALLARM, we have trained over 1,000 people to do Marcellus monitoring as a collective movement since the start of 2010. ALLARM, I said before, we're just shy of 600. The highlighted areas are some of the counties that we've been in. So, okay. So we started at 3:10, so I think we have until 4:30. So we have a half hour to play with meters and to do an activity in our workshops that we do with our volunteers. Before we get to that, what we have, well, first thing to know is our manual and a whole mess of resources are available to anyone who wants to use them off of our website. And we're also developing an online toolkit with voiceover PowerPoints, other training videos and things like that, which will be launched this spring. It better be launched this spring anyway. So that's something to know. If you want to see the manual in person, go to there. It's a 40-page document. Before we get started with the hands-on activity, I would like just to watch our meter video. So one thing to know with these meters is, well, you'll take a look. Watch the meter video and then follow the directions as we're going through the meter activity. That